I like using visuals to help understand things like calculations and equations because it just makes more sense to me. And pictures sometimes just help solidify the topic a little bit more. So maybe you already understood how to calculate GFR just by looking at the list and me giving you the formula. Let's look at this in a more visual way. So here's the situation. We have a subject who's gone into a clinic and their plasma concentration of creatinine, which is found in the blood, is calculated to be 1 milligram per liter. So what that means is that every time a liter of blood turns into filtrate, a liter is filtered, 1 milligram of creatinine is also filtered. When that 1 milligram of creatinine travels through the tubule doesn't reabsorb it. There's a little secretion, but we'll ignore that for now. Goes through and it's excreted. So every time 1 milligram of creatinine is collected, that must have meant that a liter of fluid was first filtered. So at the end of this all, when a sample of urine is collected and given within the clinic, blood plasma concentration is measured, and then measurement of the urine, and it's discovered that 90 milligrams of creatinine are in 1 liter of urine. How many liters of fluid must have been filtered in order to produce that concentration of creatinine, but also taking into account total urine volume? So let's put those numbers in the equation. We have the concentration of creatinine in the urine on the top, 90 milligrams per liter, multiplied by the total urine volume, so 2 liters per day, divided by the concentration of creatinine in the blood plasma, 1 milligram per liter. Now the numbers aren't the hard part here. 90 times 2 is 180, divided by 1 is still 180, but how do we get the units? Unless you're recently into math, maybe you've forgotten about units and how we cross things out, I actually find it easier to write it out this way. 90 milligrams per liter multiplied by 2 liters per day divided by the reciprocal, 1, which is really multiplied, but 1 milligram per liter, we flip it. So now you can cross out the units. So we can cross out the units on the top and the units on the bottom that are the same. So we've got a liter on the top, can cross it out, liter on the bottom. We have a milligram on the top and we have a milligram on the bottom of this calculation. So we have left is liters on the top per day. So 180 liters per day is their GFR. Had we not looked at the concentration of plasma creatinine, you might just look at the concentration of creatinine in urine, and you might get a false sense of what someone's GFR actually is. So what if this person actually had a higher concentration of creatinine in their blood? What if instead they had a concentration of 2 milligrams per liter, but they still produce 90 milligrams of creatinine in the liter of urine? In this instance, for every 1 liter of blood that is filtered becomes filtrate, 2 milligrams of creatinine is filtered. That 2 milligrams travels through the tubule and is excreted. And we can measure how many times that happens by looking at the concentration of creatinine in urine. So in this instance, it would be 90 milligrams per liter, which is their urine, multiplied, let's take, for example, to simplify, they produce the same amount of urine per day, 2 liters per day, divided by the concentration in their blood, which in this case is higher, it's double, 2 milligrams per liter. So now you do the math, this individual actually has a GFR of 90 liters per day. So they're actually not filtering enough. So it's always important to look at the concentration of creatinine in the blood plasma to see what's available for filtration.